Okay, today we're going to be starting a new topic. Well, not really new, but we'll be looking at indices and surds. And to start off the chapter, we're going to be just recapping something that we did at the normal mathematics, normal IGCSE mathematics. Okay, so we're going to look today at just simplifying expressions using indices. Okay, now just to recap, when we think about indices, right, we have something that has a number, right? We'll call that number A, and this number is what we call the base. And we can raise that base by something that we call the index, right? Or another word is the exponent, or sometimes even called the power, okay? And just for interest's sake, the plural of index is indices, which is where we are, what we're studying. So we're looking at indices in general. Now there are 9 rules that we need to remember when it comes to indices. Okay, we're just going to recap them. If you need to go back and look at them again, then I suggest you do that now. But we're just going to be looking at the rules, and that's it. So the first rule we would have learned when we studied the laws of indices was that if we have some number and we raise that power to another number and we multiply that by a number with the same base, and that gets raised to another number, to simplify the operations we can just add the exponents, right? So if we raise a base to a power and we multiply that by the same base to another power, we just add the exponents. That was the most simple and basic rule we would have learned. And very similar, if we took a base to some power and we divided it by a base to some power, we could simplify that as subtracting the exponents. Now another way to write that, which we can remember, is another form of writing a to the power of m divided by a to the power of n would just be a to the power of m over a to the power of m. And they both work the same way, where we can just subtract the exponents. That would have been law number 3 or 2. Okay, law number 3 would have said if we have some number and we raise it to a power, and then we raise that base which has been raised to a power by another power, then we can just multiply the exponents. Then, if we have some base raised to a power multiplied by another number but raised to the same power, this can be simplified as the two numbers multiplied by each other raised to that power. Okay, and this comes from the fact that it actually works backward, because of when we raise something in a bracket by power, the laws of distribution, we would have had to raise everything in the bracket by the power. And so we can just work backwards, that if we have two numbers that are raised by the same power, we can just multiply the bases together and raise them by that power. And in exactly the same way, if we have a number raised to a power divided by another number raised to the same power, we can simplify that as the numbers divided by each other raised to the power. Okay, again, coming from the laws of distribution, where this would have had to be distributed to both numbers. Okay, moving on to rule 6. Okay, if we have any number raised to the power of 0, it will always be equal to 1. Right, then we have rule number 7. If we have a number and we raise that to a negative number it is exactly the same as saying 1 over that number raised to a number. Okay, so a negative number in front of the exponent just means that it belongs underneath the divide line. Rule number 8, if we have a number raised to 1 over some number, it's just shorthand for saying we're looking for the nth root or the root of that number. And finally, rule number 9, if we have a number which has been raised to some power divided by some other number, this can be rewritten two ways, either as the square root of the denominator, the base raised to the numerator, or alternatively we could have the base rooted by the denominator and everything raised by the numerator. They are interchangeable, those two expressions. Okay, so those are the 9 laws of indices. It's very important that we understand how they work and we remember them, because we need to use them, especially when we want to simplify expressions involving indices. So let's take a look at an example. Here we have a expression that we are asked to simplify, and one thing we can note is there are multiple things that need to be done here. We have some multiply signs, we have a divide sign, we have things in the square root, we have things in brackets being raised to another power, the same on the denominator, and so we need to take these things one step at a time. So the first thing we'll do is we're going to ignore the multiply and the divide sign, because those operations will generally be done last. We're going to look at everything in the bracket, and remembering that a square root is also just a form of a bracket. So let's take a look at these individually. If we take 4x squared y squared, we need to raise everything in the bracket by the power. Okay, and we'll get to that in a second. Now the square root of a number, if we remember our laws of indices, law number 8, the square root of a number can just be written as the base to the power of 1 over 2. So this would be 9x to the power of 6, y to the power of 2, all raised to the power of a half. Okay. So basically raising something to the power of half is the same as taking the square root. And we are dividing all of this by x cubed y squared to the power of minus 2. And we're going to distribute this 2 into the bracket into all the terms. So let's do that step first. We're going to distribute all these powers into the brackets, and we need to remember this is a power being raised to another power, and so we need to multiply the exponents. So we're going to have 4. The 4 actually has a power 1. It's just we don't write it. So we're going to get 4 squared. Then we're going to get x squared. We're going to raise that by another power of 2, so we're going to multiply by 2. And y, we have 1 times 2. All of this is being multiplied by 9, and we're going to raise this to the power of a half. We have x to the power of 6 times a half, and we have y to the power of 2 times a half. We're distributing that half to all the terms, and because we're raising it to another power, we are multiplying the exponents. And this all gets divided by, then we'll do the same thing on the bottom here. So we're going to distribute that negative 2, so we'll have x to the power of 3 times negative 2. We'll put it in brackets so we don't forget the minus sign. Y to the power of 2 times by minus 2. So let's simplify all of that. So we're going to have 4 squared, which is 16, x to the power of 4, y to the power of 2, multiplied by 9 to the power of half, so that's the square root of 9, which is 3. We're going to have x to the power of 6 times a half, which is 3, y to the power of 2 times a half, which is 1, and we're going to divide that by x to the power of 3 times minus 2 is minus 6, y to the power of 2 times minus 2 is minus 4. Now we can basically solve everything in one step, remembering that when we multiply powers with the same base, we add, and when we divide, we subtract. So we'll do the coefficients first. 16 times 3 is just going to be 48. We're going to have x to the power of 4 plus 3, and then we're going to divide minus 6. That's why we always put minus signs in a bracket. And then we're going to have y to the power of 2. We're multiplying that, so we're going to add that 1 and then subtract the negative 4. And this finally gives us an answer of 48 x to the power of 7 plus 3. So we'll have 13. And y to the power of 3 plus 4, which is 7. Right, another type of question we could be asked is we can be given some exponential expression, and we're asked to evaluate the powers of all the bases. So in essence, what they're asking us to do is convert all the numbers we're given into these three bases, and they want to know what the index, exponent, or power of each of these is going to be. So let's have a look at what we have here. We have the number 36, so we need to break the number up into its prime factors. We know they're prime factors because they tell us what the two bases are. They're kind of hinting at what the bases should be. So 36 can be broken into 4 and 9. And those can be further broken into 2 squared and 3 squared. So we're going to change 36 into those two numbers. So instead of writing 36, I'm going to write 2 squared, 3 squared, because that's 36. X to the power of 4, and we're raising all of that to the power of 2. And then we are dividing. We have 8. 8 is not one of the numbers we're given. We need to change that. 8 can be broken into its prime factors 2, and it'll be 2 cubed. So instead of writing 8, I'm going to write 2 cubed x squared multiplied by 3x. Right, now I need to expand out. We have an exponent raised in a bracket, so we need to simplify that first. So we have 2 squared raised to the power of 2. We multiply the exponents, we'll get 4. 3 squared, same thing, we'll get 3 to the power of 4. Then we'll get x to the power of 4 raised to the power of 2, so we multiply and we'll get 8. And we'll divide all of this by, well, we're multiplying on the bottom. So we're going to have 2 cubed 3. There's only one 3. We have x squared times x. So we're multiplying the same base, so we can add the exponents and we'll get x cubed. And the final step, we're dividing, so we can just subtract the exponents. So we have 2 to the power of 4, divide by 2 to the power of 3. That's 4 minus 3, which gives us 2 to the power of 1. We have 3 to the power of 4, divide by 3 to the power of 1. That'll give us 3 to the power of 3. X to the power of 8, divide by x to the power of 3. Again, subtract the exponents, we'll get x to the power of 5. And we can remember we were asked to evaluate this as 2 to the power of a, 3 to the power of b, x to the power of c, and we're just going to compare the exponents of each of these numbers. And we can very easily see that a should be 1, b will be 3, and c will be 5. So that's just a different way that they could ask this kind of question.